All right, we're going to practice two more completing the square problems. So here I have x squared plus 7x plus 3 equals 0. So step one is you subtract 3 from both sides. You'll get x squared plus 7x equals negative 3. Done with that step. And again, I don't need to bother in this problem with step 2 because my leading coefficient is 1 right here, the number in front of the x squared. So that's not necessary. Now I need to figure out what my n is so that I can find my n squared. So if 2n is equal to 7, because that's my x term, then n is equal to 7 over 2. Yes, leave it as a fraction. Now n squared would be 7 over 2 squared. Well, that is 7 times 7, which is 49, 2 times 2, which is 4. So 49 over 4. All right. So that means that that's what I'm going to add in to both sides of my equation. So I have x squared plus 7x equals negative 7. Is that really? Oops, equals negative 3. There we go, negative 3. And now I'm going to add in 49 over 4. Right? That's what I'm adding to both sides. It's not going to be pretty, but I'm going to add it nevertheless. Right? And I'm going to do it over here as well. 49 over 4. Because whatever you do to the left-hand side, you have to do the right-hand side to keep it bare and balanced. Okay, so now this is x. Now remember, it's always going to be plus or minus n. And you already figured out what n was, right? Because of this box right here. So it's always going to be your n squared. But we already said that our n was 7/2, right? So I know that it's going to be x plus 7/2 squared. You are completing the square, right? You're changing this form to something that will be a perfect square on purpose. And then now we need to do this. Well, 3 is 12 over 4, so that's negative 12 over 4, which is, let's see, 37 over 4. Now, if you're not sure about that or you want to do it again, right? Negative 3 plus 49 divided by 4. And then you could always hit the math 1 button. And there it is, 37 over 4. Ooh, or you could do negative 3 plus, and then hit the alpha F1 key and pick number 1. And you could say 49 over 4. I'm using my arrow keys to get around there. Enter. And it'll automatically give you 37 over 4. That's the alpha F1 key. See the green part, F1? You could also get that with the math menu. Right? So either way, you get 37 over 4 if you didn't feel like doing that in your head like I just did. And you get this. All right, so now step 2 is done. Or step 3, excuse me. Step 2 we didn't need. So step 3 is done. So now I'm going to have to work that in here. So I know it's 7/2, and I know this is 37 over 4. Isn't that what we just came up with? Yep, 37 over 4. Okay, well, let's see. That's x plus 7/2. When you take the square root like that, you're going to get what's underneath there called the radicand. So it's x plus 7/2 equals plus or minus. Now let's see here. Let's break this down. This is the square root of 37 over the square root of 4. So that's x plus 7/2 equals plus or minus square root of 37 over 2. 37, I believe, is prime, so we don't really have to worry too much about it. And then you're just going to subtract 7/2 from both sides. Do it to the left, you got to do it to the right. There you go. They're not like terms over there. So your final result is negative 7/2 plus or minus square root of 37 over 2. If you want, since they're both over 2, you could write it all in one. Here, hold on. There you go. All right, so I could say x equals negative 7. Here, let me write it this way. There you go. Negative 7 plus or minus 37 over, because it's all over the same denominator. Either one of those is completely acceptable to me. There we go. All right, last one, going to be the hardest one because we don't have a leading coefficient of 1 here. No, we don't. We have a leading coefficient of 3. So let me type this up. 3x squared minus 3x minus 2 equals 0. So our first mission is going to be to add 2 to both sides. Okay, so we'll have 3x squared minus 3x equals 2. Now, for the first time ever, we are going to have to divide to make x squared 1, right? You need your leading coefficient of x squared to be 1. Let's put it that way. So we need a step 2 in here that we've never needed before. So let me take a moment and put that in there. Okay, now to make, oops, there we go. To make it so that the leading coefficient will be 1, what you need to do is divide by 3. And you have to do it to both sides of the equation. So 3 divided by 3 would be 1. Matter of fact, I think it'll be easier if you see it this way. Hold on. If I make it, this term has to be divided by 3, and this term has to be divided by 3, and this term, everything has to get divided by 3 because 3 is your leading coefficient. So that'll make it x squared minus x equals 2/3. Beautiful. There's step 2. Okay, so now we need to figure out what our middle term is, right? So our coefficient of x was minus 1. Isn't that what it was? Yeah, minus 1x. Okay, so because minus 1 was our coefficient of x. So that means that n is negative 1/2, right? So you divide both sides by 2. Now what happens if you square negative 1/2? So if you square that, that's negative 1/2 times negative 1/2. And that, by definition, is positive, first of all, because a negative times a negative is positive. And then 1 times 1 is 1, 2 times 2 is 4. So there's your n squared right there. And then there's your n right there. So minus 1/2 if you like. The minus can go either up on top or can go out in front. Okay, so then I'm going to use that fact, and that's what I'm going to add in. So this was x squared minus x equals, and then this over here was, I want to say 3/2, 2/3. Okay, so 2/3. Okay, so I'm going to use that, and now I'm going to use the number I just found, which is n squared, and we said it was 1/4. So I'm going to add it to both sides. So I'm going to add it to the right. I'm going to add it to the left. Right here. There we go. Now, by definition, when you do that, what you're doing is setting up a perfect square. So it's x minus something squared. You can tell it's minus because there's a minus right over here. Right? X minus something squared equals whatever this number is. Okay, x minus what, though? Well, it's always n. Right? That is the definition in this little box right here. It's always n, always. And we figured out already that n was negative 1/2 right here. So it's x minus 1/2. Oop, not there. There we go. So it's x minus 1/2 squared equals whatever this is. Well, you need a like denominator, so you'd multiply the one on the left by 4 over 4. So that'd make you 8 over 12. And on the one on the right by 3 over 3, that'd make 3 over 12. And 8 over 12 plus 3 over 12 is 11 over 12. Now, if that was like, whoa, wait a second. So you can do this with a calculator, right? So 2 over 3 plus, what was it, 1 over 4? 1 over 4. Math, it'll give you a decimal. Press math number 1, enter. Or you can use that other technique where you say F1, use number 1, 2 over 3, use your arrow keys, plus alpha F1, pick number 1. You're telling it to do a fraction, numerator over denominator. See the FRAC button, frac? So you're taking fraction, and then 1 over 4. Oopsie. 1 over 4. There we go. Enter. And then automatically it's 11 over 12. So either way, you're going to get it. 11/12. All right, so now we're going to take the square root of both sides of that sucker. Right? The whole reason for doing this was to make it so that you could take the square root of both sides. So I'm going to have the square root of the right-hand side, or the left-hand side, equals the square root of the right-hand side plus or minus. And then by definition on the left, you're going to have x minus a half, because the squaring and the square root are inverse functions of each other. Now over here, let's break that up. That's going to be the square root of 11 over the square root of 12. Uh-oh. Well, you are not allowed to leave a square root in a denominator like that. And there's a few different ways we could simplify this, but let's be smart about this. What we want is we want to make it so that it's a perfect square. 12 is not a perfect square. 4 times 3 is what 12 is. So you got the 4 perfect square, but the 3 is not. So what we could do is we could multiply it by the square root of 3 over the square root of 3. That'll turn it into 36, and 36 is a perfect square. So have x, oops, that's a minus sign, sorry. X minus 1/2 equals plus or minus square root 33 on the top over the square root of 36 on the bottom. That's x minus 1/2 equals plus or minus square root of 33, because that's 3 times 11, those are both prime, over 6. And now just add a half to both sides, and you'll have it. So let's see. Over here, add a half. And if I do it over here on the right, I've got to do it over here on the left, vice versa, all that good stuff. Beautiful. And those are not like terms, so you're just going to have to write it 1/2 plus or minus, oops, plus or minus square root of 33 over 6. And you have it. All right. All done with solving using completing the square. And again, it's not pretty, but it works, right? Every time. But it's pretty brutal, right? And one other comment real quickly before we go is that completing the square, the technique, the whole step 1, 2, and 3 part, not the 4 part where you actually use it to solve, but really where, honestly, this part right here, where you figure out what your n is, and then you add n squared to both sides, that step, part 3, step 3 in the green, that isn't necessarily used just for solving. You can use that for all sorts of things. And it's pretty common to use it in some upper level pre-calculus and calculus. Right? So the technique itself is not just for solving quadratics, but it's helpful for solving quadratics, but it gets used for other stuff as well. All right, so we're all done with completing the square, and it's pretty ugly. So we're hoping there's another method that we could use for quadratics. So remember, we know how to factor, but factoring only works for factorable problems. We know how to do the square root, and that works great if there's something squared to begin with. But we just learned that if it's not something squared to begin with, it's pretty ugly to turn it into something squared to begin with, right? So, and that's what completing the square is. It manipulates the form to turn it into something you can use the square root method on. But it's pretty ugly. Even though it works for all quadratics, it's kind of unpleasant. So there's got to be another way, and there is, and it's the quadratic formula. So we'll see you here next time for that video where we go over the quadratic formula. See you right there. See you then.